So in this case, we're saying we're doing it. If the count is greater than 0, we pass it the field, the found minus 1, and then this, which is the current result from the previous cycle through. And if it's not empty, then we put a paragraph return because we don't want an empty return paragraph at the very beginning of the list. And then we get the nth record. So it's a slightly different structure to the code, but by doing it this way, we are never hanging on to anything in any given cycle through this function. I don't know. I hope this.
Would you be able to would it be possible to draw that out?
Or dance.
Sure.
If you think you can.
If I think I can, we'll see.
It's probably one of the most difficult things to absorb out of all the stuff we're doing.
Let me see if there's anything else. Well, that was the last topic that I was going to cover. I was going to open up for discussion. So if you want to spend more time talking about recursion and tail length recursion, we can certainly try and plow our way through it. Or if there's other issues you'd like to discuss also, we can do that. And I have, 12 minutes to do this?
Can you do that in 12 minutes? I think this is more important than if you get this.
I mean, this is fundamental. This is fundamental stuff. And I mean, this is a very trivial example, but there are cases now. I mean, there are lots of, like, if you have to deal with more than 50,000 records, you're hosed anyway. Okay, let me talk about that for a minute. Okay, iteration. There's these two topics: iteration and recursion. Iteration is do this, now do this, now do this, now do that. Okay, recursion is do it, do it, do it, do it. Okay, until you're done. So FileMaker has, in the calculation engine of FileMaker, there's a built-in limitation of 50,000 iterations. So you can't do more than 50, pardon me?
Calls. You just use iterations for levels.
Yes. Well, yes. Well, it's calls, it's the call stack, you've got 50,000.
Well, I'm just saying you use the term iterations for the other one. That's okay, go ahead. Sorry.
Okay, I'm sorry.
Can you authoritatively what you mean by iteration?
An iteration would be
The procedure calling itself.
Levels.
well, levels in the call stack, right? So calls to other functions, calls to other scripts. There's a call stack in FileMaker that's limited to 50,000.
So you're talking like from within the script itself, not from within the recursive function.
Well, no, it would work either way.
Well, I mean,
Okay, the recursive
combined
function is,
together, if the script starts,
the most,
gets
the
stuck
most
at
you can do
50,000.
is 50,000 in FileMaker in any calculation engine environment.
Sorry, I'm going to try to redeem myself, sorry.
No, please.
So,
and let's try and clarify this, because if I'm not doing it clearly, I want it to be clear.
And so I think of it in terms of levels. So you call a custom function, and it calls itself, but before it's done, it has to call itself. So if you think of it as going deeper and deeper, all of those calls are alive until it resolves and works its way back up.
Okay, and that's where, in that case, you're limited to the 10,000. That's
Exactly.
the 10,000 case.
Right.
But at a deeper level within the calc engine, there's this 50,000 iteration limit, which is separate from the 10,000 recursion limit. Okay, and there may be a tie-in to it, maybe the amount of overhead for them to support the recursive call uses up 3 or 4 iterations. Okay, but I just know, I mean, I just did this last night, I was testing this, and sure enough, right around 10,000, this guy fails, this guy keeps humming right along. I mean, here, with the full 49,000, while we're talking, we'll let it, cook, and you'll see that it works. So with the tail recursion approach, you can use up close to almost the entire 50,000 call stack that FileMaker provides available. But when you don't use it, you're limited to 10,000. Okay, if you have to go more than 50,000, you can't do it. Not in the FileMaker environment. So you have to do it some other. You have to do it. Write the data out to.
What about phase 2?
Yeah.
So can you try to attempt
Can I
to
try?
explain the difference between, grammatically, the difference between recursion and tail recursion?
Okay, if I have a function me see if I haven't really thought
With a
about it.
darker pen, maybe?
Well, I'm feeling insecure.
It's got away from the camera.
So I have some parameters get passed into this thing, and it's going to do some work. And it determines it needs to call another instance of itself, right? Which needs to call another instance, okay? All of these, in a non-tail recursion, this one isn't done yet. It's calling this one, but it hasn't finished. It's waiting for this guy to give it back its result, which is calling this guy and is waiting for it to give back its result. Okay, now let's,
And that's your 10,000 limit, right?
all right, so now let's say so now we're in this one. This one finishes, and now it's at the last one. There's no more to do. So it gives the result to this one, which now gives the result to this one, which now gives the result to this one, which gives you the result that you need. Okay, this is not tail recursive, because this guy is still alive, this guy is still alive, this guy is still alive, until this guy finishes, at which point he unwinds. Okay, in a tail recursion environment, it might be represented more like this, where you have the original call, which does some work, and then finishes and calls itself again. So you're not keeping all these instances of the thing running. You have one instance, it does some work, and it spits back the result. It just so happens that the result it's spitting back is to another copy of itself again, but you just have the one active. That's why I had the 3 parameters, one of which was the current result, the current list. So this does the work, it figures out what it needs to do, it's done, there's no, it's not like you're saying take the current one and the result of the calculation of it again. It's just, okay, call me again with these new values.
All right, and in that circumstances, you can do 50,000.
You can do almost 50,000. See? There's 49,990.
Can you add 10 to that, see what happens?
Pardon me? Yeah. No, but if you go to 50,000, it breaks. I don't know where between 4990. I just deleted 10 records and then do it work. Yes.
Do you have a sense as to, given the smaller amount of data, less than 10,000, which method is faster?
That's a good question. I've never benchmarked it, and I may be perverse, but well, I'm definitely perverse. But I tend to view debuggability of code over performance almost every day of the week until the client or the environment dictates otherwise.
I hear you. And which one do you think is easier to debug?
This one is way easier to write. It's more natural because, like in our case, if I was to do this in pseudocode, for example, this model here, okay, I have a list of, right, whatever, like this. It'd be like, take the last one, and do it again, right, of, the list minus the last one. It's kind of, I don't know if this is, okay, but it's like, take the last value, and now do myself again with everything from before. And since I'm just appending it, it's really easy to read. Because it's like, oh, yeah, that makes sense. Okay, so in most of my, I'll be honest, in most of my actual implementations where I'm dealing with I'm almost certainly dealing with less than 10,000, things, it's like, fine, just do it. It's just a lot easier. But if you think you might get close to it, or there might be some issue about it, or you want to, impress your significant other with your tail recursive capabilities, then you can't do this and that. You have to just return the result. So you have a case statement that says, if I'm on the last one, return the whole thing. Otherwise, call me again with these following parameters. So you're not appending the 2 bits. Yes?
If you're on a not so powerful client, it would seem that the tail would be much better because you don't have memory hog.
Yes, it can use up a lot of memory, but most machines, but 10,000 is like eat in most computers these days.
I just tested it, and it's at least twice as fast.
The tail
version is at least twice as fast.
Hey, okay, so
Really?
okay, so your homework assignment is to all write a tail recursive custom function by this time tomorrow.
Yeah, that's fair. That's a fair assignment, actually. I would like that. People would do that.
that
How do you
tail,
your file's available in here, right?
Nope,
Oh.
file is not available.
Oh.